This is the picture that you can see is the building where I'm in right now. So this is the city of Aachen, at least some part of it. We just recently got some nice drone shots. We have some other shots where you can see our nice cathedral. But I preferred this kind of perspective. And why did I do so? Because I think it illustrates quite nicely what you already discussed yesterday. And that is, so we have this university building here in the front. So this building, this is where we are located. This is university. We have some university buildings within the city. So you can already see that university and the city of Aachen, they are combined together. Yeah, so you cannot really separate it. And yeah, and then you see something in the background, yeah, which are the clouds here. This is steam from a nearby coal-fired power plant. Yeah, so we are in the middle of the so-called Rheinisches Revier. That's like an area where we have lots of lignite, so coal, yeah, brown coal, and several power plants that use this coal to generate electricity. So we have many different players, and if we as university want to become carbon neutral, we cannot do it alone. We always have to do it together with the city and with many other stakeholders which are around. So this is kind of nicely summarized in this picture. So, but that's the introduction. The topic for this kind of workshop is what we call circularity. So the overall theme of the summer school is climate change and university campuses. And now we want to focus on circularity. And what does circularity mean? Well, for us, it's one word. It's like a short version of circular economy. So circular economy, probably you know what it is, so that we kind of want to have closed material cycles. For example, plastic waste or plastic circular economy, where we don't want to have plastic waste in the oceans, and we want to use the waste as a resource for recycled material. But that's not the focus of today, at least not plastics. It's more about the carbon and the CO2. So like the circularity with respect to climate change, or in other words, it's about a circular carbon economy with the goal that we want to have a closed circle, yeah, or in other terms, again, we want to become carbon or climate neutral. Yeah, so like, or net zero is another word for this. So I don't want to bother you with so many words and definitions, but I hope that you have a little bit better feeling what we want to do here. But nevertheless, I would like to know what kind of expectations you have, or what things come to your mind if you hear the words circularity and climate change and university campuses. And so just go to this website. I think you've used it yesterday already, menti.com, and use this code and enter 3 words or phrases that come to your mind. Could be anything. Could be your feelings that you have that makes you happy. Yeah, I don't know, angry or whatever. Could be solutions that you have in mind. Whatever it is, just yeah, write it down. So wait a second, maybe it has not started yet. So it should work. It should work now. Well, at least we'll see when the first one has entered some words. So what do you think when you hear circularity, climate neutral, climate change, and university campuses? The first word is challenging. So any other feelings? Whoa, okay. So challenges again. information and data leadership, responsibility, certainly, root of awareness, zero waste, closing the chain, knowledge-based solution, research and innovation. Of course, we had university, neutral emissions, sustainability in a much more broader perspective. What needed? Yeah, it's needed. Expertise, we need expertise. Lead the way, be a leader in terms of circularity, being bold. And yeah, so you can see some words get bigger and bigger, such as responsibility, the challenges, sustainability, and yeah, priorities is another word that we see. All right, so I think we've seen like 16 people who added words. So yeah, we'll save the results and give me just a second. Okay, so yeah, that's it's good to see, and we will come back to what you wrote later. But I think it makes clear that yeah, definitely we have a responsibility. Kind of, we should be a leader. We should do it. And what we also see, it's definitely challenging, and we need a lot of expertise, research, and development. So yeah, so now that you've heard this, we would like to ask a second question, where you just have 3 options. Is a carbon neutral university possible? Is it feasible at all? So now with circularity, we mean carbon neutral. Is it possible, or is it a definitely no-go, or are you not sure yet? You think, okay, it definitely depends on some yeah, circumstances and so on. All right. Okay, so we have nobody who's really yeah, pessimistic and thinks it's not possible at all. We should not even try it. I mean, otherwise, I guess you would not be here and use your time to get to know more about this topic. But I'm very glad that many of you say it's possible, and well, I put it there, but let's do it. So let's be bold. Let's take the lead. Okay. So I will save that as well, and then we will. So just a second. Okay, perfect. So yeah, thanks for your feedback. And now we will dive into the topic. I will give you first an overview of what we'll be doing in this workshop. I will give you like a 45-minute lecture, so to say, on circularity for climate mitigation on university campuses. So all those buzzwords combined, and we will, after that, we will have a session for some time dedicated for questions and answers. But please use the possibility to raise questions during my talk. Yeah, you raise your hand in Zoom or unmute yourself and ask questions. I guess we're just a few people, so I would really like it to be as interactive as possible. Okay, so after this lecture and questions, then it's your charge, or you're in charge, and we will have a workshop in 3 sessions, where the overall goal in all sessions is to reflect and discuss carbon neutrality for university campuses. And we will do so from 3 different perspectives. And these are the 3 groups that you will be assigned to. Okay, then there will be a short break probably, and then we have a presentation of the group results where each group presents about 10 minutes the thoughts and the information they collected. Then we will have a short wrap up of this session, and then at 5 p.m. So there will be a break, and then at 5 p.m. there will be the overall wrap up for today. Okay, so we start looking into circularity and how we can become carbon neutral. And I would always, I like to start at the very beginning. And this is the carbon cycle, how it used to look like some 100 or 1,000 years ago. So you see a little picture of our beautiful Earth and the carbon cycle. Yeah, and that's like some years before the Industrial Revolution or before humans were on the planet in large numbers. And the message is it was this closed carbon cycle. Yeah, there were always carbon fluxes from different compartments. For example, in biomass, soils and vegetation, there's carbon stored in the leaves and the trees and organic matter in the soil. And that is released into the atmosphere, but of course the plants take it back to build new structures, and we have a closed circle here. And the same thing at the oceans, we have carbonic acid, which you maybe know from carbonated drinks. So we also have some carbon in different forms in the oceans, and we have a circle here as well due to the evaporation of water and so on. And then something happened. We came onto the Earth in larger numbers, and we were hungry for energy, or not only energy. First of all, we were hungry for wood to build ships. We also wanted to have land for agriculture, and then we also used fossil fuels. And all of this changed the carbon cycle dramatically. So we have some emissions of CO2 or carbon, carbon in the form of CO2 into the atmosphere. And if you look at the numbers, this is like 9 gigatons. Doesn't really matter how big or what that number means to you. And a lot of people say, well, this is a small number, 9 gigatons, compared to the fluxes that we have in the natural carbon cycle. But that really doesn't matter, because what happens is, well, the natural carbon cycle responds. We take a little bit more CO2 in the biogenic carbon cycle, also at the oceans, but we still have like a residual amount of CO2 that will be stored in the atmosphere, meaning that we will accumulate CO2 in the atmosphere, and the consequence we have a temperature increase in the atmosphere. So, and maybe as a side fact, we also have increased carbon in the oceans. We changed the carbonic acid, we changed the pH in the oceans. We have ocean acidification, and that's also not good for coral reefs, for example, and other species. So that's the status. And of course, the ideal is to have a closed carbon cycle again. So what do? We could stop all our activities. We know from Corona, stopping our activities and kind of not living anymore, or like a very reduced amount, is not what we like to do. So, but we still should reduce emissions and change, for example, to renewable energy. But then again, we see that we cannot really eliminate emissions in all of the sectors that we have. So one idea would be, okay, we have a natural cycle in the biomass part in the oceans. Why don't we have a closed anthropogenic carbon cycle? Or do something, maybe I forgot to say that, okay, we don't want to have it in the atmosphere. What if we just store the carbon somewhere else? One idea is to put it underground, which is called CCS, carbon capture and storage. But at least in Germany, we don't like to do that. But that's an option that we do. And we say, okay, we can rely on our old industry, do business as usual, and then we just store the carbon somewhere else. Well, that's an option. But as I said, another option would be to say, okay, we establish our own carbon cycle. Yeah, we use the CO2 that's coming out of the chimneys and purify it, use it again, reconvert it into materials that we can use as fuels again, or as materials. So, and why do we want to do so? Or when is it a clever idea to do so? Well, the thing is, whenever we close cycles, it doesn't come for free. We have to invest energy. You can think about a roller coaster, where you have a looping. If you go down, of course, the roller coaster gets faster because energy is released. But then if you want to go up again, you have to invest energy, or the energy that's stored in your velocity, the kinetic energy goes down. So that's the same thing here. And if you think about this analogy of a roller coaster again, if you start at the bottom and you want to have a nice ride, you go down, you have a looping, and then, I don't know, go back again. Of course, without adding energy, you will not come to the same altitude again, because you have losses. You have to invest energy for each round that you do. And the same is true if you want to recycle CO2. So what does it mean? It means we need energy, and that's kind of the tricky part. Most of the CO2 that we're producing right now comes from energy supply. And we are now talking about this CO2 recycling as a solution to our energy problem, but what we need is more energy. So we're not really solving the problem, okay? Means it only makes sense, for example, if we use renewable energy, or if we use it for materials where we really need it. And we have lots of materials that rely on carbon, and for those kind of options, it doesn't make sense. And I will give you an overview of where it makes sense, and also because, as I said, so it doesn't solve the energy problem, and we see that if you look at the overall, so the worldwide CO2 or greenhouse gas emissions by sector, so 3/4 more or less is energy related. And we should switch this energy to renewable energy. You've heard about this yesterday. What we want to focus on today is more like the rest. So we have industry, we have waste, we have agriculture, where we have CO2 emissions or greenhouse gas emissions, where it's very hard to avoid those emissions. And there we're thinking about, can we close this cycle? And one thing that we also want to focus on, or that I would like to show you, is chemicals. So with this, the CO2 recycling is also called CO2 capture and utilization, because there are two parts to it. First of all, you have to capture the CO2. You can do this from the sources that we have, where we emit CO2, for example, the power plants or any industrial processes. But it's still diluted, some, let's say, 10 to 15, 20% of CO2 concentration, and we typically have to purify it in order to use it. And for that you need a lot of energy. And then again, with the CO2 you can do different things, but typically you also have to invest energy. So, and the easiest thing to do is to use CO2 as it is. So maybe there's a use for CO2. And this is an icon for a fire extinguisher. And there it is used. Why? I mean, CO2 is like the burnt carbon. It's already burned. It will not burn anymore. So you can use it as a fire extinguisher. That's easy. You can use pure CO2. However, what we typically like to do is we want to convert it into different materials. And there are different ways to do so. One way is, okay, we just insert the carbon molecule into a bigger molecule. For example, polymers, plastics. Yeah, this is this kind of option. And then there would be a third option is CO2 reduction. Yeah, that's what it's called, where you're not really interested in the CO2, but you're only interested in the C molecule, so this black bubble here. And what you have to do is you have to get rid of one or two of the oxygen molecules, so the red bubbles. And to get rid of this, you have to cut this bond, and that requires a lot of energy. But you get molecules that we know. For example, this here is supposed to be methane. That's kind of the main part of natural gas. So it's like a synthetic natural gas that we can use for energy purposes again. But as you might know, so if we kind of, so what we do today is we use natural gas and burn it to go back to CO2, and we get energy from it. So now if we go the other way around, we invert it, we have CO2 and want to produce this molecule, we have to invest a lot. So, and of course, it doesn't really make sense if we, let's say, kind of go back and forth all the time, unless we want to, for example, store energy or transport energy from one place to another. So, but I mean, this part in the middle is something that we like to do, for example, in the chemical industry for plastics, because I don't know, you have plastics in clothes, you have plastics for your running shoes, you have plastics and carbon fibers in maybe in your bike. So there's a need for this, and now, okay, let's at least make it from CO2 with a closed carbon cycle. So that's the idea. And now with this, or maybe something that I already said on this slide is, so first of all, we should reduce the emissions as best as we can. Yeah. So for example, by eliminating this big chunk of emissions coming from energy supply, by switching to renewables. But then we still have, 1/4 of emissions in other sectors, and there we could use this idea, for example. The question is, or the question that a lot of people say is, well, if we have this kind of cycle, think about the roller coaster, you're once going up and then going down again. Going up and down all the time doesn't give you any value as such. In other words, if you think about a carbon balance, the best case will be it's carbon neutral because you're just circulating the CO2. Nothing comes out, that's okay. So it's like carbon neutral, but let's say the energy that you get is at least the same, or is smaller than what you have to invest. So in principle, you're also releasing some sort of CO2. So what other people say is, okay, reducing emissions, and recycling emissions are two options, but that's not enough. We have to have another option, which is we have to remove CO2 from the atmosphere. And why do we have to do this? And that's what I want to show you on this slide. So on the left side, you see there's Ed Hawkins. It's a scientist who is active in climate research, but also very great in visualization. He is also famous for the global warming stripes. I don't know if you heard about it, but that's like another visualization, and you can see how the average global temperature is rising more and more. And we would like to stay within 1.5 degrees Celsius or 2 degrees Celsius. So that's what, and where does this temperature come from? It comes from the amount of CO2 that is in the atmosphere. And even, so you've heard about we should become carbon neutral by 2050, or maybe 2040, 2038, whatever it is. we're now talking about becoming carbon neutral. But what happens if we become carbon neutral? We still have too much CO2 in the atmosphere. We've already put so much of the CO2 into the atmosphere, and it's a long-living greenhouse gas. It will stay there for a lot of 100 years, and it will keep absorbing radiation. So it gets warmer and warmer, even if we completely stop emitting CO2 emissions. Yeah. So, and what we need to do to keep the temperature in balance or within this 1.5 degree, we have to remove CO2 from the atmosphere. Yeah, so it's not only circularity, it's also becoming carbon negative. And there are kind of negative emission technologies. One is, for example, direct air capture, where you suck the air from the atmosphere. There's just a little bit of CO2 in there. So it's 400 ppm, that's like 0.004%. I don't know if I missed the zero or not, but you see it's very, very small. Yeah, it's like finding the needle in the haystack. Yeah, you have to invest a lot of energy to extract this little CO2 from the air. You have to push a lot of air through ventilators. That's very energy intensive to get a few CO2 out of it. But we have to get out, we have to move a lot of CO2, so you can imagine how much air we have to clean and how much energy we need. But it's kind of the last resort. Science says we have to do it. Yeah, from 2050 on, kind of. That's the fifth assessment report from IPCC. Where you have different pathways for achieving 1.5 degrees Celsius. And in most of the scenarios we have, that's like the CO2 emissions over time. So we have to get negative at some point. Overall, on a global scale, to get negative. Okay, and that's where I want to leave it with the technology perspective. Yeah? So maybe sum up again. Yesterday, the energy workshop was about reducing CO2 emissions by switching to renewable energy. But then we have other sectors where we can recycle it. And with the same kind of technology, we can also suck CO2 out of the atmosphere or from other sources and then store it somewhere else. Of course, we have to store it, something that also not everybody likes. But it's kind of consensus that we have to do it. So, and now that's very general. We want to transfer that to the university campuses. So we are now on a very global perspective, and it's a huge challenge for us to see what does it mean for university. Is everything energy related and renewable energies is just fine, or do we also have the problem of having some greenhouse gas emission sources that we cannot avoid, where we need this negative emissions to kind of, or this recycling to compensate. And also if we think about beyond 2050, what can we as universities do to contribute to removing CO2 from the air? So that's what we are now focused on, different perspective from this very global technical part now to our university campuses. And the big question is, first of all, how do we start? And how do we get started? And then the question is, get started for what? As I just said, we're now talking about keeping this 1.5 degree temperature increase. And mostly that means we're then talking about carbon neutrality at some point. But we could also discuss whether we have to be carbon negative at some point. But let's say, okay, we now take the goal, and that's the first part. We want to be net zero, so no more emissions. Or maybe we have emissions, but we compensate in some other way. And that's, there's a race from the United Nations, the Race to Zero, so Race to Zero Emissions, where the Idea Leagues and also other universities are in the process of joining. And this Race to Zero has also clear it helps the universities to reach the goal, and by giving them some guidance. And the first thing to do is, okay, the universities, the presidents and the rectors, they have to pledge, meaning they have to say, okay, we have a goal for net zero that we want to meet as soon as possible, and we will commit to this goal. That's the very first step. We have, in science, the goal is clear, but now universities have to articulate the goal and write it down and say, yes, we'll do it. Sounds obvious, but it's not so easy because you have to convince a lot of people at the university. And then what I will talk about now a little bit is, okay, how do we plan this? And based on this, we will then discuss, okay, how do we proceed? How do we really take actions? Because here we just plan the actions, here we do it, and then transparency is always very important. And here it means we have to publish an annual report saying where do we stand, what are the measures, and how successful are we on the way. So now we have the pledge, we have the goal. Now we need a plan. So, and if you think back to this global perspective, we also had a goal, 1.5 degrees Celsius, and we discussed some plans, or at least some options and the challenges. But the very first step that we did with the carbon cycle is we looked at the status quo. So we have to know, first of all, how many greenhouse gas emissions do we have? And there's a so-called greenhouse gas protocol that helps you in how to calculate and report your CO2 emissions. Mostly it's done by companies nowadays, but it can be used for any sort of organization. For example, university campuses. Because the first question would be, which CO2 emissions do you report? Which CO2 emissions are we as a university accountable for? Which of all the emissions that are going to the atmosphere stem from the operation of a university campus? And there, in the terms of the greenhouse gas protocol, there are different scopes. Now, the first scope is the direct emissions that you produce. For example, we have buildings on our campuses that need heating in winter times or maybe cooling in summer times, and so we need energy, and the energy is provided on campus where we use fossil fuels and produce CO2. So there's a chimney on the campus where CO2 comes out. Those are our direct emissions. That's what we put into the atmosphere. But of course, that's not all, because I just mentioned energy. For example, in Aachen, we have a particular situation or special situation that we really produce our energy on campus to a large degree. But of course, you can say, okay, we don't do it anymore. We just buy it from a utility provider. But of course, then you just shift the emissions to the provider. So there's a second scope. And since energy, we saw that before, is typically a big chunk of it, that's like the emissions that you kind of buy in from purchasing energy. Most electricity, fossil or heat, where fossil fuels are burned, and so on. But then again, you have even more emissions that you are accountable for, and this is scope 3. So everything else which is needed to run a university, or a company. And this is, you have to buy goods and services. You need capital goods, you need buildings, You need business travel. The employees and the students, they have to commute to go to campus and back home. Then also you have waste that has to be treated on this is like the downstream activities, so stuff that you have to get rid of, so to say. And with all of this, there are emissions associated, and ideally you should report and track all of these emissions so that you have a full picture and avoid shifting emissions from one scope to the other. All right, so good news is universities are already doing it. So let's have a look at two selected examples. One is University of Twente from the Netherlands, so very close by to where I am right now. And the other one is Victoria University of Wellington in New Zealand. Yeah, and New Zealand is very different from the Netherlands, and you can see that in their reporting. So let's look at Twente from the Netherlands. We have some total emissions. Okay, I cannot even say whether that's large or not, but let's look at the distribution. We have 63% coming from electricity that is generated or bought from the University of Twente. So that's the biggest part. Then we have car travel. We don't know who is traveling, employees or students. Then we have gas, which is burned on campus. We have flights, for example, to summer schools or conferences. We have district heating and some others. So, okay, so this is very much energy related, a little bit of transportation. For New Zealand, it's very different. Of course, there's also electricity, there's natural gas, there's also land transport, 18%, a little bit more than the 12% in Twente. But for example, here we have air travel, which is 29%, which is much more than the 3% from Twente. I mean, it's obvious, you're living on an island, whenever you want to go somewhere, you have to use planes. So not surprisingly, kind of air travel is more important over here. So the message here is you have to do it for your university to get a clear picture, and then okay, typically you want to address the biggest parts first because it's typically it's easier, because also your time, your resources, your efforts are limited. For everything that you do, you have to convince people and so on. So focus on the first things first. Okay, those are two examples. There's a nice overview study of many university carbon reports. So I don't want to go into detail. Different companies: Germany, Ireland, Chile, Mexico, Belgium, Singapore, Great Britain, Australia, and USA. And well, you can have a look at it, but let's say the big chunks are energy, mobility, and then something else. And here again, we see differences. For example, here, UBC Birkenfeld from Germany, most of the emissions come from this bright blue, which is student commuting. And so what does it mean? It means whether there are other students go to campus by car because it's somewhere very remote, or it means that this part is very big because they are very efficient in all the other activities already. So you don't know what it means. Or it could also mean, and that's the tricky part of the greenhouse gas protocol, you can say, I report these activities and I don't report some others. So maybe they were very careful in reporting student commuting, whereas let's say another university in Germany, to make it comparable in Lüneburg, they have no student commuting. Maybe because they go to campus by bike, or because simply they don't report it. So that's something that you have to have in mind. But let's not get lost in the details. The message is, first step is you have to get an overview where do your emissions come from. And you don't have to be as precise as possible, but the first step, my advice would be to get a broader perspective. Okay, and then you know kind of where you can attack and what you can implement. And with this, I would stop this this first lecture here and open up the floor for any questions that you have. Could be on anything related to university campuses or to the CO2 recycling that we talked about in the beginning.